Welcome to April's Leetcode challenge. Today's problem is ones and zeros. You are given an array of binary strings and two integers, m and n. Return the size of the largest subset of strings such that there are at most m zeros and n ones inside the subset. A set X is a subset of a set Y if all elements of X are also elements of Y. So I don't know why they worded it like that, but we have a bunch of strings with ones and zeros. We have a limit to how many ones and zeros we can have, and we want to return the one with the largest number of subsets. So here we can see that we can include all four of these, maximizing our constraint with 5 zeros and 3 ones, and we'll have a length of 4. So we want to return that 4. So initially when I saw this problem, I thought perhaps there's going to be a greedy approach to it if we sorted it by the length of these strings and then tried to just go through it and maximize our number of ones and zeros. But the reason that's not going to work is, say that we had, for example, like 1, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, and I said, oh, you can have 3 ones and 4 zeros or something like that. Or actually, you want 6 zeros. Well, if we did something like this, what would happen is, since it's sorted by length, it would first take this 1, 1, then it would take this 0, 0, 1, but then we can't take anymore because we've already completed our 3 ones. But that's not going to be the answer, right? Because the maximum here is going to be all 3 of these, not just these 2. So a greedy approach isn't going to work. And once I realized that, you realize pretty quickly there's really only a recursive approach to go. You have to do something recursive. So we can do that. We can brute force it and check every single combination of strings or subsets and see which one, completes our constraint and is the longest. But to do that would be very inefficient. If there's a recursive solution, usually there's a dynamic programming solution as well. So we do have constraints. Let's see. We know that the m represents number of zeros and n equals the maximum number of ones, right? So what we can do then is have like a DP array here that's going to contain, say that we had a maximum of 2 ones and, I don't know, 1 0 or something like that. We can have this be representative of how many zeros we can have on the row level and how many ones we can have on the column level. We need one extra row to account for 0. These will always be baseline 0, because if we have a constraint of 0 ones, that means there's nothing that we can use to put into that subset. So what we can do is kind of dynamically go back, say that we start with 2 ones and 1, like say that we're given this number here. We can check at the maximum, move backward and say, all right, well, we know that 1, 1 and 1, or we can do 1, 1 and 1, 0 here. So if we had a constraint of 2 ones and 1, 0, let's move back 1, 1 here and see if we can add to whatever's before there. So here we see that's 1. Then we can move back here to say this is going to represent 1, 1 and 1, 0. Again, we move back to say, all right, well, before, if we had completed that, what could we do? And get the max between this and this here plus 1. So here we can see that's 1 as well. And for this example, that would be it. But just think about it as like we are maximizing our constraint and then moving backwards all the way to the point that we can't fit this substring inside anymore. And by moving backwards and adding to what we had before, we could find, kind of build up the number of strings using this dynamic programming array. So let's start by creating a DP array, and that's just going to be a nested for loop. So for I in range of, this is going to be number of ones, right? And this would be for j in range of number of zeros that we can use, plus 1, remember, and this would just be 0 right here. So now that we have our DP array, what we'll do is do a nested for loop for every string inside of our strings. and basically move through all the m times n's that we could use here. So let's see, for, call this I in range of n minus n, but we're going to move backwards, right? So it's going to be n that we calculate, and the first thing I suppose we need to do is count up the number of ones and zeros inside of our string. So ones is going to be s time count of ones, while zeros is going to be s count of zeros. So for I in range of n, moving back to all the number of ones, n equals ones. So we've already calculated this. This kind of makes sure that we're not going to go out of bounds here. And I'm actually going to minus 1 here for the indexing. For j in range of m, zeros, s1, minus 1. So now let's update our DP array. So this is going to be dp of ij is equal to the max of dp ij. Or, let's see, it's going to be dp I minus ones, j minus zeros, plus 1. So this is going to build up this DP array, and at the very end, we just need to return our DP of, let's see, ones, zeros, ones. So let's make sure, let's see if this works. Okay, I think I flipped this. All right, so that does look like it works. Here, let me just print out the DP array to show you what it kind of looks like. And you can see essentially the last cell here represents the maximum m and n that we can use. And all these previous ones represent like smaller constraints. So we've been building up the number of strings that we can add. And by moving backwards, we can make sure that we're not going to recount certain numbers when we update our DP. You can certainly move upwards if you'd like, but if you want to do that, you would have to have like a temporary DP array in the middle here. So moving backwards is a little more efficient. Let's see if this works and submit it. And there we go, accepted. So time complexity wise, it's going to be m times n times s, I suppose. We do use m times n space. And yeah, that's it. This is probably the most optimal. So one thing here, I do want to, I think some of you are under the misconception that I solve these blind and I come up with this like in this same progression. Definitely not. Like once I realized this was a recursive solution, I essentially had to look for help and saw a solution that looked like this and thought this one was the best one. I'm just, trying to understand the solution and relaying that back to you guys. That is totally different from solving this blind. Like I've attempted to solve some of these blind and make videos, but I've found them unwatchable. So if one day I get to that point, I will release more blind solved videos. And perhaps then I'll even monetize them, trying to focus more on the quality of these videos. So, but until then, I'm just going to brute force it, grind my way through, just like you guys are doing as well. So thanks for watching my channel. Remember, do not trust me. I know nothing.